Okay, yaar bachcho, we have to study the impact of stretch on the graph of a given equation or on the given graph. Okay, before I go into the stretch in functions, I should revise the stretch as it is. Um, that what do we mean by stretching a point? Okay, so guys, when we talk about stretch, the first thing that you should know, the first term maybe, that is the invariant line. Okay, the invariant line. um, if you want to know that what do you mean by the invariant line, then you must relate it with the center of enlargement. Okay. Now suppose here is a point O and you have a triangle over here. Let's say this is a triangle ABC. So when you are going to enlarge this triangle from this point O with a scale factor 2. Okay. Now, this O is the center of enlargement and your scale factor, which is known as K, that is equal to 2. Okay. So you have to basically change the distances of all these points from O. So that would mean कि okay, if this A is situated suppose करें 2 centimeters from O, then this A dash would be over here at a distance of 4 centimeter. That is your A dash. Okay. Similarly, if your B is situated, let's say this is 1.5, suppose. Okay. So this would be in the same direction over here. So here you will have at twice the distance of OB, you will have this OB dash. Okay. And similarly, this C, whatever the distance is C from here, it is going to be over here. Okay. So then the image, the enlarged image of this triangle is going to be like, somewhere here. Like if it's, okay, if I had used a ruler, then you could have seen that, like, this side could have been longer. Anyhow, so the point is that you are determining the distances of the object and the image from the center of enlargement. Okay. So, I hope you people have recalled the concept or the term center of enlargement, because this is, you have done this in your O levels. Have you been able to recall that what do we mean by center of enlargement? Yes?
Yes, sir.
Okay. Now, when we are going to talk about this stretch, so in stretch, it is in fact all the things that we do in the enlargement that will be done in stretch, but in stretch, we take the distance of these points A, B, and C from a line. And in your syllabus, that can be a vertical or horizontal line. And to be more precise, in your syllabus, this line with this invariant line can be the x-axis or it can be the y-axis. Okay. Now let me tell you that how does it operate. Now suppose if you want to stretch this, the same triangle ABC, if you want to stretch, then you need to have the invariant line, which can be a vertical line or a horizontal line. Okay. So let me show you what will happen to this if you stretch this with a scale factor 2. Okay. Let me give you a little bit idea over here first. Okay. Do you know what do you mean by the distance of a point from a line? Suppose here is a point X. You want to determine the distance of this point from this line over here, from this line L. So what do we mean by the distance of this point from the line? If I say there has to be a word added before the distance of,
Perpendicular
yeah,
distance.
very good. It has to be the perpendicular distance of a point from a line. So whenever we determine the distance of a point from a line, it has to be the perpendicular distance. Okay. So obviously then you will see, okay, this is, suppose this is this much, let's say this is 1 unit over here and the scale factor is 2. So you will double that distance. So now this x dash would be over here, okay? Okay? And suppose here is your y. So this y would be moving onto this. This is your y and this is going to be your y dash, okay? And suppose there is a point over here, which is z. This triangle is like this. So you will double this distance as well. So your z dash would be coming here. So this triangle would look like this after a horizontal stretch. Okay, so you can imagine that if we stretch this horizontally, this triangle, you see that A dash would be anywhere onto this line, B dash would be anywhere onto this line, and the C dash would also be anywhere onto this line. So depending on the scale factor, you might see that this triangle might look like this, okay, like this and this. After a horizontal stretch, this might look like this, okay? And where we perform this horizontal stretch, we can also see that how do we perform the vertical stretch. Now, suppose if a triangle is like this over here, let's say this is how the triangle looks. So after a vertical stretch, you see that now the locus of the images of these points would be like this, because you have to move perpendicular from the invariant line, okay, through these points. Okay, so suppose if you have stretched this vertically, so this triangle, depending on the scale factor, should look like this. Okay, so when you're stretching something vertically, the distances of all these corresponding points, they change according to the scale factor from the invariant line. Okay, so these are the key words over here. One is the invariant line, then you have the scale factor, okay, and then if you have a vertical invariant line, you see that this stretch is horizontal. Your object has been stretched horizontally, okay. If you have a horizontal invariant line, so you have seen that your image has been stretched vertically, okay. So if your invariant line is horizontal, okay, so this means it's a vertical stretch, okay. Guys, if you're stretching something vertically, so which coordinate do you think would be changed? Hmm?
The
If
Y
something is
coordinate.
being stretched vertically, so which coordinate do you think should be changing?
Y coordinate.
Huh?
The
Yes?
Y coordinate.
The y coordinate. And similarly, if you are stretching something vertically, okay, if there is a vertical stretch, I mean, you have a vertical invariant line, okay, and then you have the horizontal stretch. So you must know that in a horizontal stretch, you see that this x coordinate over here is going to be twice than this x coordinate over here. Okay, if this invariant line is the y axis over here. Okay, so when you have a vertical invariant line, so there is going to be a horizontal stretch, okay? And the vertical stretch has an impact on the y coordinates, okay? And the horizontal stretch has an impact on the x coordinates, okay? Now, how do we show this in the functions notation? That what do we mean by all this? Okay, so look at this now. I need to cover these things up here so that I can give you some notes here. Maybe I can cover this much, okay? Okay, guys, so please see that when you have a vertical stretch, you people have told me that, you know, what is happening, where is the impact that is on the y coordinate. So let me give you a very simple example. Now, suppose if you have an equation which is y is equal to x square plus 1, okay? That is y is equal to x square. Oh, I can take this example over here. Yes. Oh, we have we have something here already. Let's use this example here. Okay. Let me. Oh, I can't. No. Let me take it back. Okay. Guys, I believe that you people can look at this diagram over here. Okay. Now, first, let me complete my example over here. Now, if this is the equation y is equal to x squared plus 1, and you want to stretch this vertically with a scale factor 2. So that means all the y coordinates would be doubled. So you will be writing it as y is equal to 2 into x squared plus 1. Okay. So I hope this makes sense because all of this is representing your y basically. Okay. So for example, if there is your x, there is your y. Suppose when you put 0, your y is 1. Okay. When you put x is 1, your y is 2. Okay. And when you put your x as 2, your y is going to be 5. Okay. And then after that stretch, when you have stretched with the scale factor 2, so I believe you people will understand that now this y dash would be 2, 4, and 10 because the scale factor over here is 2. So the y coordinates, they have to be doubled. Do you people understand that what am I writing over here with this 2, 4, 10? What is happening to these y coordinates and why it is happening like this? Hmm?
Yes.
Anna? Achha, now look at this example over here. You have been, I wish if I could have shown you a bit enlarged over here. Now the equation is y is equal to, let me note it down here. I can write it myself a bit bigger. Okay. Now the equation for this is, okay, now this one over here, it has an equation which is y equal to x square minus 2x minus 3. This curve is the object over here. Okay, remember before the transformation you have an object. Okay, the image has an equation here which is written in red. Y is equal to 2 into x squared minus 2x minus 3. So you see the way I did that, I multiplied this whole expression by 2 so that I can show you that the scale factor is twice. All the y-axis, y coordinates are being doubled over here. Okay. So in this example, that the sketch we have, it's the same. Now look at what is happening with the y coordinates. Okay, if you guys see that the y coordinate over here, can you see this y coordinate? This y coordinate is minus 4 here. Okay, and after being stretched, look at this. Where is this y coordinate going? This has gone on to minus 8. Are you clear why did this go onto the uh, minus 8? Why this turning point has further gone down the x-axis? Can
Yes,
someone
sir.
please help us?
Yes, sir.
Hmm? Yes, Bacho?
Sir, was that -3 before and it's at -6 now, the point?
Yeah, because the distance over here that was already 2 below the x-axis, and this has to be doubled as I showed you in my examples. Okay, so this is what happens to the y coordinates of the points when you stretch that from the x-axis. You see, this is your invariant line over here. This x-axis is the invariant line. Okay, so this is going to be moving, all these points are moving vertically now. Okay, so the impact is on the y coordinates over here. Okay, look at this point is 4,5. Can you see this point? This point is 4,5, and now this point is 4,10. You see, so the y coordinate was 5 and now it has gone on to 10. So that is what happens to the coordinates of the, of the points on a curve when it is stretched vertically. Okay. So now please note it down that when you have y equal to f of x, okay, and this is changed like this, a times f of x, okay? So this represents a vertical stretch, okay, with a scale factor, a. Okay, if your equation is y equal to f of x, this has become y is equal to a times f of x. So this is going to represent a vertical stretch. Okay, so in the next segment, I'll tell you about the horizontal stretch, guys.